Have you ever been outside and it started raining? Well, if so, did you wonder how much it had rained, how much humidity there was, how much sunlight your plants had received, and how much they'd grown? And also if there had been any lightning? Well, then we have the product for you.
So we've built two different rain gauges. This one's more for home use with all sorts of sensors as well. Whilst we've also built another rain gauge, which is more so for agricultural environment, these remote areas with ultra low power and just measuring the rainfall.
All right, so this is our rain gauge. So firstly, we've got this LED display here that displays between two screens. One of the screens shows rainfall and the pasture height. The pasture height is detected from two ultrasonic sensors here at the bottom. And then there's also a buzzer which triggers every time that this bucket flips, which is every time that 2 milliliters worth of water is filled in this rain gauge. And so that's displayed, like it counts it, and then it measures it, and so that's what's displayed here on the screen. There's also this photoresistor here, and if it's dark out or if you cover the sensor, then this blue LED will turn on. And this whole thing is powered by solar power. And then on the inside of the device, there's also a temperature sensor, a humidity sensor, and a lighting sensor as well.
So here we have a Nano-Satellite rain gauge version. Here it's powered by a solar panel as well, and we have Muriota's Nano-Satellite module on a surface mount PCB, and we have an antenna as well here. And you can see behind there's a surface mounted reed switch on the back, and when you go in you can see that it's completely isolated, and so that the magnet here actually passes through the plastic casing, which is very different to a lot of rain gauges currently on market, which have the rain gauge inside the tipping bucket, which means that the elements actually exposed to the water and can corrode and reduce the reliability, whereas all these components are completely isolated. So here we have the LED display. Now pins going backwards, pins 16 and 15 are the LED minus and LED plus pins, which essentially provide the backlight for the LCD 16:2 display. And then since we're using a 4-bit mode, we only use the DB4 to DB7 pins to save the number of pins, which all go to digital pins and essentially provide the data to the LCD. And then we also have the E pin and the E pin, which is the enable pin that enables writing to the registers, and that connects to the MOSI digital MOSI pin. And then we also have a RS pin, which connects to another digital MISO pin. And we tie read write down to ground so that it's always in reading mode. And we also connected a potentiometer to V0, which controls the contrast, and VDD to 5 volts to enable the microcontroller, which provides power to microcontroller, and VSS, which is ground for the MCU on the LCD chip. So here we have the reed switch, and the reed switch uses both capacitors and resistors to help with the bouncing effect of once the magnet passes, it can record multiple results, which were registered on Arduino, and so it helps smooth that out. But the problem is we get a normal high value, and because we want to interrupt the Arduino or the Muriota module only when it registers an event, we use a Schmitt inverter, Schmitt trigger inverter, to swap the result from high to low, so it's at a normal low. And once the magnet passes, the resistor, it will register high and wake up the module.
I won't go into too much detail for the sake of time, but here you can see our overall diagram, the many different sensors that are connected to different pins on the Arduino. Yeah, no, I didn't really have any problems soldering all the tiny components together at all, no.